Hi, good day. I am Kent Benedict Cabucos, and today we're going to talk about forecasting for my operation management subject. For our first activity, the objective is to obtain data on a daily weather forecast of high temperature for 7 days. As you've seen in the screen, so we have completed the first objective to obtain a data for 7 days for weather forecast for my local news so after that is compare the accuracy of local 1 day forecast with 1 day naive forecast. So we're going to talk about we're going today I'm going to talk about MAD, MSE or MSD or and MAP. Are the summary for accuracy. For MAD means for MAD it means mean absolute deviation, so it expresses the accuracy in the same unit as the data, which for MSE or MSD, also called MSD, a commonly used mean square deviation, a commonly used measure for accuracy of fitted time series values. For MAP or MAPE, mean absolute percentage error, so this expresses the accuracy as a percentage of the error. Because this number is a percentage, it can be easier to understand than the other statistics. So after that is we're going to use a 1 day naive for a 1 day for every 1 hour. So I choose from 7 a.m. to 12 a.m. and this is the actual temperature in Celsius. So what is naive? Let's go to the book first. I'm sorry for the lag. So naive is a forecast uses a single previous value of a time as the basis of forecast. So the naive approach can be used to table series with seasonal variation or with trend. So with a table series, the less data point become the forecast for the next period. So how are we going to use the naive method in Excel? First is we are just copying the first actual temperature and after that so on so forth. So the last is the next day forecast. After that is we're going to use a forecast error. So forecast error is just the difference between the actual temperature and the forecast, so we get these values. After that is the absolute forecast error. Absolute is just we're just going to absolute the forecast error so that we can get a positive values. And for that we can use the MAD. For MAD again, the formula is actual minus forecast over n. So we're just going to average this so we get a 3.8 MAD. For the squared error is we're just going to square the forecast error, so we can get our MSE is we're just squared plus n minus 1, right? I think there's some problem, so sum, we're going to use the sum 15 over 4, that divided by how many? 1 2 3 4 5 1 2 3 4 5 divided by 5 minus 1, so we get a 14.4 MSE. For our percent error is we're just going to multiply, right? Multiply everything. We're just going to average it. For percent error is we just multiply 100 times the absolute forecast over the actual temperature, so we get a MAPE which is 14.68. So I think that our is not really accurate because I think this the our accuracy, our summary is 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 higher than 0 or greater than 0, or they are, what is the meaning of closer, that they are not close, not so close with 0. Don't know what's the English for that. Not so close, greater than or greater than 0. So for our so let's go for the activity 2. So for the activity 2 is we're going to gather data, a 5-day data, high temperature, and a 2 weeks actual forecast, and we're going to use 4 methods. So first is we're going to use the naive method. So again, just like the other, nothing changes. I think it will change the MSE. We're going to sum everything, right? We're going to sum this over n minus 1 means how many DM are. So 4 minus 1. So we get a negative 2.8. Right? I think I'm right. For MAPE, we're just going to use this, right? Oh my god. For MSE, we're just gonna change this average. No, not average, sum. Goes to sum squared error over 13 minus 1. Again, what is that? 6 minus 1. Okay, so we get a negative 10.9 squared error. 4 3. How about 13? B again, 1. No, 12. 2.3. And for moving average, let's go to book what is moving average. The moving average, again, sorry for the lag. For moving, so one of the weakness of naive method is the forecast just traces the actual data, so with a lag of 1 period. It does not smooth at all, but by expanding the amount of historical data a forecast is based on, this difficulty can overcome a moving average forecast. It uses a number of the most recent actual data values in generating forecasts. The moving average forecast can be computed using this equation. So for example, is we're going to use a 3-day moving average, so meaning that we're going to neglect the first 3. The first 3. I don't know what is the word neglect. I think after that is for the forecast, the changes is that we are going to average the first 3 to get our forecast. So we're going to average the first 3, we get a 31.3, and so on. For the forecast error, we get a negative. For MAD, again, we're going to change the MSE. My calculation is wrong. So the first is we're going to somebody sum over n minus 1, so we get a 1. So we have a squared error of 0.6 and an MAP of 1.6. So for this, for this, just simple. Again, just average the first three and everything follows. We're going to change the MSE. We're going to sum everything up. Sum over 12. Yeah, the 2.2 MSE. For the 2-day weighted average is we're going to use 2 instead of 3. We are going to neglect the first 2, and we're going to use the recent. So again, we're just going to average the first 2, right? So we get a 31, 32, and I'm going to change this first. I think this is wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those, I'm sorry, 11 minus 1, so our n is 10. 2.7. For our 0.8, we're going to sum this first. Sum divided by 3 minus 1 equals to 2. So our MSE is 1.1. The problem with this is wrong. We just use these 2. And the calculation is wrong. I forget about it. So again, we're going to average the first 2. Enter, and so on and so forth. That's wrong. No. We're just going to neglect this first 2 equals to average of this first 2. Enter. And I'm going to change this 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 minus 1 equals to 11. Our n here is 11 over, so that's, after that we're going to use the exponential smoothing. For the exponential smoothing is we're going to use this formula to get our forecast. Our alpha is 0.2. Our 1 minus a is 1 minus alpha, 0 equals to 0.8. For the forecast, for the first is we're going to copy the first day actual in our first data for the forecast. After that, we're going to use, for the second day is we're going to use the formula. For our alpha is 0.2 times our actual temperature. First day 1 is 30. After that is 0.8 plus 0.8 times our forecast 30. So we get our forecast 30, so on. And we're going to change this first. Sorry for that. Sum over 4 minus 3. 4 minus 1 equals to 3. Our n is 3. And for this, I think I didn't use this. So let's do the forecasting first. First, we're going just to copy first actual, and after that, we're going to use the formula equals our alpha 0.2 times the actual temperature, the 28, plus our 1 minus 8 or the 0.8 times our forecast. So we have a 28. So we're just going to copy this. Whoop. Whoop, whoop. So that forecast error. Sorry for that. Forecast error. For squared error. For percent error. we're just going to change our MSE. MSE, how many are they? 13 minus 1, 12. Sum divided by 12. After that, this is the summary. Wait, let me change it first. I shuffled it. So we can see, I think one day naive is still the best technique because it is closer to 0, as you've seen, in 5 days and 2 weeks than the other methods. And also I think the 2 weeks is more accurate because there are a lot of data as seen in MAPE, as seen in the summary. So I conclude that one day naive is one of the still good technique in forecasting, and more data is best for forecasting to get an accurate data. Thank you.